So I'm not 75, but I'm feeling that way nowadays. I'll tell you that much. 40, I think I'm 46, I forget. I forget on purpose at this point. I'll stay 46 for a little while. Yeah, off by one. I was born in Manhattan. I'm from New York, but I grew up in upstate New York. And upstate New York is pretty much an IBM town. And I guess I can flip to this screen. I have to put this on because it kind of paid my way. I guess I worked there. So this is kind of like a brief just rundown of who I am and what I do. I've given some other talks. Most of the time I give these talks at HushCon just because they're of sensitive nature. But like for the last like 15 years or so, my friends have been like, you have to give a mainframe talk. You have this knowledge and you grew up in upstate New York and this is where they were fabricated, this is where they're made, this is where they do the debugging. And there were some guys who were damn close to 75, like some real true OGs. Like they could look at a stack trace from, it was RISC from 1964 and just read it. And I was like almost like a wizard. I don't know how they did it. So did some Active Directory stuff. You can all type in like how to get domain admin in Google, #1 search. Everyone that I know is like literally nauseated at me saying that so much. So new crowd, I thought I'd say it. So you kind of span different stuff here. These aren't all the talks I gave because some of them are even a little bit more, they're just more shiesty. So this is hacking big iron with AI. I could have honestly probably have not done AI, and I use it every day, but I thought, why not run the other way? Like everyone is doing AI talks. So I said to myself, like, maybe there's a good chance if I don't do AI, specifically an AI talk, it'll give me a better shot at getting some comments. So far, it's working pretty good. I must say, if I don't toot my own horn. This is an image I generated with AI about like your typical obnoxious American coming to Sweden. It was pretty, yeah, sadly enough, that's true. Yeah, I'm excited to be here. It's a beautiful country. And thank you for having me. Everyone, Security Fest, fantastic conference. Why does this actually matter? Like, why am I here? I would say that I'm here because these things process like 30 billion transactions a day, at least in the States. And then I actually have some interesting information about you guys as well. That was I didn't even know about it until I think last night. But there's no EDRs on ZOS. They don't even make them. If there's anyone out here who, can correct me, I don't think so. They do run MVS and ZOS. So the gentleman who said to me, if you get a B your freshman year, went to a New York State school, we will give you a job. And that was how I kind of got this job. I was 18 when I first started working on things. I'm now 93. 73% of Fortune 500s run ZOS. So I talk a little bit about the history. I'll go over that. I'll start with the Watson project, which costed more than the Manhattan project. And there's a lot of API integrations. There's Kubernetes that run on these things and a lot of other, I don't even know at this point. Because when I left in 2000, the big thing that they had done at that point was a bunch of hackers in Germany during the course of a summer had basically ported SUSE Linux to the IBM mainframe. So we were in meetings and they were talking about like, do we patent these algorithms? And I was like, this is so freaking IBM. Like patenting algorithms, patenting like different kind of thought patterns. And I was like, well, joking around and being a young punk, I was like, you should call it like Blue Hat. That was my 2 cents in that conversation. I had nothing to do. So you guys have been, I think, one of the only countries that have actually been, well, documented. I'm sure America gets popped every day. That actually had 2 mainframe intrusions where it was a bunch of like the ex-pirate guy. I have a picture of him. It's kind of funny, and 3 other culprits that got access to, I guess, like the holding company of Volvo. These guys were gnarly. I mean, they were able to laterally move and then get root access on a shell. And this was like 2013, and like the main players in this field, and I'll talk about them, it's really like one guy, like Soldier Fortran. And Soldier of Fortran's like just been spearheading a lot of the research for the last, like, as far as I can remember. I met him at a DEF CON, and I said to him, hey, I did this at an energy company. He was just like, you're hired. And I was just like, what? Like, okay. I had a job at that point, but right about now, I'd probably say, okay, for reals. So my employer should not hear. This is the actual guy who popped at the point, this was ZOS, it's 2013. And, a lot of the times when you think about these guys, you think about some super hacker, but this kind of fits the motif. Looks like he has some Faraday cage around here with a tin foil, bunch of Ethernet cable. I thought that was kind of befitting. The origin of mainframes is kind of interesting. Basically, like Watson was like, we're going to build this thing. I don't care how much money it costs. $5 billion in 1964 was a lot of money. It was, I hinted at this before, it was more money than Project Manhattan. So he was dead set on making sure that this thing was the best mainframe. I mean, before that, IBM had a shiesty history of basically selling calculators, and that's what they were. And they used those, they sent them to Nazi Germany. Even when I was working there and interning there, when I was going up to school, Watson School of Engineering, go figure. I guess it was a co-op, not an internship, so I had 5 years or 5 summers of working there. And there was like a Nazi medal. Like, I kid you not, just because they had sold these machines to the Nazis to count all the people that Nazi Germany didn't like. I don't have to go into specifics when it comes to Nazis up here. I don't know if that's the best thing. So System 360. So this is System 360. It is one of the main things about it that really differentiated it was a single system. There was, backwards compatibility. IBM really wanted to make sure that these systems would work. So Watson said, like, and still to this day, ZOS will run the same code set. That's why, like, those graybeards who could look at the stack traces, they've been working on stuff for 25, 30 years. When I was at IBM, there would be people there who honestly never cashed a paycheck. You would hear these like stories about these guys who just did not care about money. They cared about basically MVS. And when you hear about mainframes, they're usually conflated with I was talking with really, really smart people just before, and they're like, we have a guy that does mainframes. And I'm like, oh, well, what kind of mainframes does he do? And they're usually A400s. They're not usually MVS systems, just because these things are big, they're expensive, it honestly need a raise for, and you can see like all the tape backups. I forgot, but when IBM, I don't know if it was for the mainframe, but they have like this great picture of like a hard drive, and it's like the size of like a B-52, and they're like loading into the bay. IBM sold they sold a lot of their divisions over the time, and obviously they missed the whole PC computer kind of thing. So 8-bit standardization was one of the big things that came about during System 360, and then kind of what I hinted at was the backwards compatibility. System 370 comes around, and its goal is to be used a lot for academic research and things like that. And there's they come out with like these concepts of virtual memory, dynamic address translation, and they basically take them from a company called Atlas, or a corporation that's based out of Manchester, the University of Manchester. And Atlas was the first to actually come up with these ideas, and IBM kind of group sums them and says like, okay, these are now mine. Like, I'm going to grab these, and I'm going to make these part of MVS. So MVS, like, kind of, it's still got like, it still looks like something out of like a cockpit of an airplane. It's analog-ish. It's not fully digital at this point. You can tell by all the, all the levers and knobs, but it paves the way for MVS. So MVS multiple, it's a mainframe virtualization system. Still to this day, like when I was working, it was called MVS. ZOS is just a marketing term. Better reliability, and once again, they wanted to be able to make sure that this thing, I kind of said it twice, they want to make sure this thing's compatible. Kind of like how you can run Objective-C code on I think like everything from a NeXT computer to like the most modern OS that there is. Same kind of idea. This was the bad boy that I got to work on. System 390. These things were gigantimous. And when I used to work at Endicott, which was IBM's first kind of like, it was their headquarters. Like IBM kind of took over the East Coast. It went down from like, tip top of New York. And then it kind of spread all the way down North Carolinas, where they had their HR department, down to different states I'm forgetting about, and then to Florida. But in East Fishkill and Poughkeepsie, which were about 2 hours from where I grew up, these bad boys were everywhere. And also, obviously, in Endicott, where I ended up doing regression testing on the hardware console element, which is a freaking laptop. But they decided to call it a hardware console element because it's IBM. And they have to come up with their own terminology, which brings them to a whole other level of bureaucracy. This was a bridge to the IBM Z platform. These things were really powerful. I remember sitting in a cafeteria and the executives would fly in, and it was like, you'd be sitting there eating your crappy IBM food, and the executives would land in their chopper and come in, and they'd be like, we just reached this many gigaflops and we were beating Hitachi. So I'd say like in the late 90s when I was there, IBM was kind of the king, when it came to just raw computational power. And they paved the way for a lot of interesting technologies. Little bit of trivia. Let me see if it's on here. This is just like kind of like a summary, System 3.7, virtual memory, blah, blah, blah. Kind of can stick by that. CICS is one of the things that I don't show, and I'm going to try to get to the live demo. So looking at my time. Yeah, so I still have some time. Where was I? So yeah, OS 390 has CICS, DB2. I was actually there when my office mate dropped a DB2 cable when I was in this like shiesty, hacker channel. And I was just like, hey, like how do you recover a DB2 table? And I'm like, guy tells me, I tell my office mate, he's kind of was just like, how the hell did you know that information? I was just like, I talked to this weird, probably Russian hacker, and he just knew how to restore the DB2 table. Kind of blew his mind. But that's what I was kind of doing when I was young and foolish. Nothing much has changed. So when I was working on these different systems, I was kind of like, I was in high school, and I kind of told the story like you get a B. Well, that's what one of the, used to be a big swimmer. Hurt myself doing it. So it's kind of hard to hurt yourself swimming, but I figured it out. I was pulled out of high school to fix mainframes I didn't know. Because like back in the day, late 90s, there was like this period where there's incredibly savvy people that were in upstate New York, especially in Kingston, Poughkeepsie. And it was IBM town. 1945 to 95, they owned that place. And I kind of slipped in where a lot of that talent had kind of fled. There was mass layoffs. I mean, meta-style layoffs. Like we're talking across the board. My friend's father was a technical writer. And then the core engineers who were writing like system drivers and, doing the really heavy lifting, they all got sent, well, not all of them, but it's kind of an overgeneralization. They got sent to Florida and other areas, I don't know. So like my friends whose father worked at IBM were the first to teach me the basics of, computation, bash process, how to bash and how to like change your prompt and do all the basics that, kids do when they're learning computation. As soon as they left, like my skill level just plummeted. Like I went from someone that was like learning how to program to someone who was just dangerous enough to hang out in these various channels and do all the stupid things that hackers and carters and freakers do. Then after a couple internships through my freshman to my senior year, I was in college for like 10 years. But my last year of college, I worked in it's not here, but this is kind of a cool fact. But I worked in Endicott. That was with the race floor. And then I also worked on race floors and just because I was doing regression testing, or I was just handling mainframes and testing these weird laptops. And so you had to get hands on keyboard. First couple of years, I don't think they trusted me, so I was kind of just behind the screen. And I have like a RAG system that I was kind of going through, and I was like looking at these IBM Red books, and I was like, I don't remember these, but I remember like the first time they were converting them from, the actual Red book to HTML. And now they're all in PDF format just because it kind of became universal. So I remember years ago looking and being like, does IBM publish these things? And most of the information is not confidential of any kind of sorts. One of the really cool things about IBM is that up to the PC4, when NVIDIA took over the world, they fabricated every single chip that went into every console. So if you had a Wii, if you had the predecessor, GameCube, Wii, up to a particular point, PlayStation 3, they came out with the cell technology. Xbox, they actually, I think Xbox, they kind of handicapped it just because, I don't know why, like they didn't want to pay them enough for the chip. The PS3 was, if you guys remember, was an incredibly powerful system, cell processing. And when I was there, it was like roughly the time that they were developing these technologies. And they promised me the sun and the moon. And just like Office Space, I had like 4 bosses. So I'd have like a manager come up to me and be like, have you worked on this? And here's your TPS report. Have you filled it out? That kind of thing. And I would be like, what do you mean? Like, I don't even know what you guys are talking about. So that was my experience working for IBM when I was up in Endicott. And just multiple times, I mean, luckily when I was interning in Poughkeepsie, they kind of had their act together. But they would eavesdrop on me. Like, they would honestly, I mean, IBM is almost an extension of the military, and you don't do that. Like I would do stupid stuff like messaging my friend, "Are you ready to have like a kegger tonight? Like, we're gonna get fucked up." My manager brought me in, but then I was kind of checked out. Like I was offered a job. I was offered multiple positions. I got to intern at the coolest part, which is the Linux, porting and feasibility, where me and a very, very smart individual just took GNU bash scripts and just converted them to System 5. I'm sorry, System 5 and Linux. Mostly Linux at that point, because Linux was the new hotness. This is kind of cool just because it talks about the history of Unix. So we had like, in the early 370s, you had different variants of, System 6, System 5. I think right around here, the guy who told me if I get a B, I think like POSIX, like right around here, probably like 94, is when he single-handedly and his team port System 5 and make it POSIX compatible. And that just automatically gave him the engineer title. So when I go to talk to him, you go into this IBM office, and there's like the word engineer above his like office cell. And it's bright green. It's so freaking IBM. Guy was really, really smart, and that obviously like bumped him up from just I don't even know what he was before, then a manager, middle manager. Unix system services start to evolve. So IBM like says we're not going to miss this bus. Like we've already missed a PC computer. We're going to invest a lot of time into making sure that we can port applications, that we can natively run them, kind of like with Kubernetes. Like, I don't know if you saw a couple of years ago, Chompy just destroy basically these mainframes by gaining access to Kubernetes and then just moving laterally. So it's similar to like your guy from 2013, except Chompy just took a little bit longer and did it on a stage. This is where I come in. Like, I literally get hired. This is my first internship or third internship. Some boring jobs, like first just manual data entry. By 1999, I am doing Linux porting and feasibility, and I kind of talked about that, so I'm sorry if I'm repeating myself. Awesome job. Like, I would work maybe 3 hours a day and clock in like 43 hours. I hope no one from IBM's here. It doesn't matter anyway. But I'd clock in like 43 hours, just write some GNU scripts, fix some basic logic, if statements, get paid a lot of money. So IBM likes this bait and switch kind of thing where when you intern there, they treat you amazingly. Like they really, really, nice meals, they don't give you too much work. And then I heard as soon as you join, you just get like a stack of work that's like on your desk. And you have to kind of go through that. 2001, I kind of stopped here. Z series comes out, and I'm kind of like at this point trying to think. I graduate. I don't really work with the rebranded ZOS. Like for me, it was always System 390. Let me see if I can run through these. Yeah, so 60 years of the same architecture, intern, or da-da-da. And security teams never really watched these guys. I want to talk about like mental models, like, just because, not to sound too much like, I'm just kind of babbling. But mental models is kind of like in the title. And, what is like a mental model? It's just a way to understand complex ideas. That's all. It's kind of like IBM jargon. Modern hackers don't. It doesn't cleanly relate like the concepts, so you have to kind of like overgeneralize them, and I kind of go through that. The attack surface is identity, it's jobs, it's data sets, it's spools, it's control panels. It's literally like job control language, which is the same exact. It's like a modernized version of a punch card. I wanted to get a bunch of punch cards, but I didn't follow through, and I didn't know if they would be the legitimate thing. So these are the control planes that I kind of talk about, like VTAM, which is like, obviously it kind of speaks for itself. This is your underlying fabric. So when you first connect to a mainframe, you're presented with this VTAM kind of interface. Because when these things were invented, there was no TCP/IP. It was like, dude or gal inside like an office, and there'd be like a cord run because they had to be in clean rooms. So be sitting there on their TN3270 clients and basically interfacing with the mainframe. So TCP/IP came along. I can't give you an exact date, but I would assume probably around late version of the System 370 because they had MV, and they started to have System 5 support. And then by System 390, it was kind of integrated in the stack, but still not. I don't know where it is today. This is the authorization engine. You can kind of think of as like a TSO is kind of like your shell. If I hate saying that, I can go over that a bunch of times. RACF is kind of like your Active Directory. There's also like top secret. JES is where the jobs are actually schedules. This is like batch processing, deferred execution. So there is no shell, and MVS is the kernel. And nowadays there's CICS. I don't have that in here because the system I'm going to show you is educational, and IBM, I can't like display like a ZOS box just because I'd get into a lot of trouble in a main stage. More of a for an NDA kind of thing. But yeah, so this kind of goes over it. Shell is your TSCL batch. RAC is your root admin. There are no files. They're all data sets, which I'll walk through. Processes are jobs. When you look at the JES and it does all its deferred execution, it comes down to spool. This is kind of interesting because there are ways to schedule it. So you can schedule the batch processing to happen during certain hours. So if you get like an influx of credit cards, all the major credit card companies were just like, no, you can't touch my mainframe. Malware persistence. So this is kind of an interesting one. There's a gentleman whose name I can't talk because it's really politically incorrect, but his first name is Charles. His first name is Big. That's all I'll give away. But he's the only person that I know who actually, even Soldier or Fortran, wasn't able to gain persistence. Or maybe he did and just didn't release it to the wild. All this other stuff is kind of lateral movement. Most of the way that people laterally move is through all the different stuff they modernized. So System 5, Linux, they started to use like FTP. And that's kind of the way that you would do it. Then you make your way to the mainframe, you laterally move there, you find a data set, create a job, and kind of execute it. This is kind of walks through that. So you'd be using your terminal. You'd enumerate the users, which I walk through. You find one with like default cred. There's like 100 IBM usernames. I don't think I've ever found a system without default credentials. You submit your job control language, which I kind of talked about before. And then you get your privilege execution. Now, I'm probably, so it's okay. So yeah, a shell is not the center. So like, that's the wrong slide. Yeah, so everyone kind of thinks about like this is one of the main reasons why I give this talk. Like, how many people here are pen testers or red teamers? Okay, how many of you have come across a mainframe? How many of you were afraid to touch the mainframe or kind of left it alone? That's why I'm here. That's really the main reason why I'm on this stage, because I've seen really, really talented red teamers and pen testers just hit a mainframe and be like, take a screenshot or watch someone else, kind of type in their commands, just because everyone's kind of using all the function keys and they walked away. So this is kind of why I'm here, because we apply a lot of these models, and cloud and web thinking have kind of dominated our current psyche. On Linux, shell is your main prize. On ZOS, execution can happen through all these different ways. There have been recently some reverse shells that didn't require FTP access, and that's that Charles guy whose name I can't say. He figured out a way to basically upload raw assembly and execute that in Jez. And then he created he modified a library, a data set, so that every once in a while it would be executed. I tell you the truth, I don't, kind of a little bit above my head. This just goes over root, like privilege is one magic account, yada, yada, yada. And then it goes through, it's kind of comparing Linux to the convoluted mainframe that it is. You log in, you do your jobs, you can log in, touch a data set or program, and then it kicks, like I said, there's like a CICS, but CICS is more of a modern invention. This is a mainframe from the 80s that I'm gonna show you with AI. And CICS implementation is kind of crappy. I don't know how else to say it. What else do we have here? This is like I've kind of gone through this. You got your cron, you got your malware, GCL, files, data sets, and standard out. Don't want to bore you guys. What else do we have? The core thesis. So everyone asks, where is the shell? Where is the trust boundary? So these are all your trust boundaries. Your TSO, your JCL, your Jez, your RACF, your data sets, your CICS, your schedulers, your stuff I don't know about. Operational reality. So this is I've kind of gone over this again. I don't want to sound like a broken record. This is what's missing. This is what it means. SIM integration is non-default, which is awesome because like IBM has such a powerful SIM. I just love that. I'm standing on the shoulders of giants. So did I say yeah. So oh god, his name is there. Oh no. This guy is awesome. He might have a very offensive name. It's obviously a play off of the different kinds of formats that you have when you deal with ASCII characters, and IBM loves to create their own. I mean, when I show you the Metasploit modules, like this guy has like the best ones as far as publishing them and making them public. Philip Young, soldier of Fortran, who I met, now he's director of NetSpy, solely focuses on just mainframe penetration testing. This guy is freaking gnarly. This is when my friend said to me, you should start giving talks, and I didn't, like 2013, 2014, or just getting out there. This is the Metasploit module for mainframes. This is the actual exploit. There's one, and that's Philip. That's Phillips. That's soldier of Fortran. This is the guy whose name I wasn't supposed to say. He's actually updated this pretty recently, and IBM, if you find a flaw, they don't care. Like they don't give you a CVE. They'll patch it silently, and that's why these guys have to kind of like play around with some of the actual code. Like you can kind of see they're doing stuff with the actual shell code, changing Bayesian operators and doing kinds of interesting stuff. IBM started as a business. They rented out computers. That was kind of what Watson did, and he's like, well, these are getting expensive to rent out. I'll make my own. This is the real problem. The real problem is most failures in mainframe are conceptual. They're not technical. So there's kind of a misunderstanding when people actually look at, how did my mainframe get popped? Mainframes are federated systems. Authority is distributed across the subsystems. We kind of went over that. And that leads us to big iron AI, which is like, oh no, is it attack pass? This is me trying to basically walk through an 80s mainframe. Let's see what else we have. So this is like the full compatibility. This is what it can do. The Bloodhound style graph is kind of a lie. I wish that it was fully functional and as awesome as Bloodhound, but the framework is there. The RAG database is pretty cool just because it actually can kind of understand and you can ask it really esoteric mainframe questions. It's got this is kind of roughly implemented. The autonomous walkthroughs, red team, and there's some other stuff here. So I'll just kind of try to get through this. AI changes the equation. You don't have to be Philip Young now. All this information is in some kind of corpus of knowledge. And now you can kind of feed it information and kind of train it if you want to go ahead and train it. Let's get to the more interesting stuff. So this is, oh, it didn't change. So let me see if I've changed my monitor here. Change this to like an extended display. Would that do it? No. Oh, I'm a fool. I can't use PowerPoint. Let me quit out of here. And now let's see. No extended display. Technical difficulty. I'm a mainframe guy, so I don't know what I'm doing. I'm like, what is this new technology? This is amazing. So this is the program I wrote. It throws up a web app. It uses a llama. It has an FTP server. It says CICS is there, but I wouldn't really count on it at this particular point. Let's see. So this is kind of like my way of trying to make it cool. Throw it back to Lululemon. You can kind of play around with it. A lot of troubleshooting went into like getting this mainframe work, so that's why I had to kind of do some debug statements here. If you click on the top here, it'll actually in real time read what's on the screen. So you'll see if I could type in random characters here. If I type this in, it'll actually start to analyze it. Invalid command, check spelling. So it's telling you literally what it is. You can do some basic stuff here. I wanted people to kind of understand the basics of what it is to log into MVS, what a VTAM session is. Just because not because I know all you guys are highly intelligent, but because this stuff is esoteric and there's not too many. I wanted to create a framework that not only kind of combined a lot of the genius of those guys who I more or less just copied, but I also wanted to create a framework that had a walkthrough and that was also able to drop some science, drop some knowledge. TSO, all that kind of boring stuff. It gets kind of more interesting here, when you go through the actual walkthroughs. So you could start this, and it will actually walk through a mainframe. It should. It'll log in, and then if you want, you can be AI tutor, tell me. Oh, geez. But yeah, it'll start asking you questions, and as it goes through and authenticates, you can click that button. For some reason, there's a demo bug, and it will actually tell you, let me see if it works now. It should. No, it's not working. But you could do explain the screen, which is more or less the same thing. I'm just probably clicking the wrong button, nerves. And it will tell you what's this ISPF kind of thing, what's it doing, and then you'll go through and it'll actually walk you through the whole kind of process as it kind of tries to catch up here. This is partially AI because I clicked analyze the screen. And all this does is log into that ISPF console, which is just another part of the TSO. It has a bunch of modules, so you can so if I stop this, you could do session stacks, you can do deferred execution, which is the way that you can kind of take over these systems. There's a lot of fun stuff. What else? So there's a little kind of fun thing if you go to the front of the let's see if I go back to IBM here. If you click full screen, I worked a lot on OS2. So it's a little, and this guy here, I spent too much time in OS2. It's not a bad operating system, and you can ask it I think you can select the screen. Does that still work? No, not here. But you can ask it different questions. Where are my questions? Error code. And this is all RAG trained, so. And then I have another section where it's another AI tutor. Let's hope it works. Give it a second. This says 64 gigabytes of RAM, but it's still slow. So it kind of walks you through, and it says it's an error message. And then you could ask it questions like, how do I write JCL and all that kind of jazz. This is completely open source. I'm MIT licensed. I don't have a QR code, but I'm more than willing to share this. I'm more than willing to give my URL. If you type in awesome cellular hacking, it will take you to the same page, and it's like, that's all you have to type in. I've been included into the awesome world. There's the labs I kind of showed you. This is kind of fun. There's like a scanner that just does like basic fingerprinting. This is where it gets kind of interesting. So you can actually do assessments, and you can run through and enumerate like who has access to VTAM, what users have access to the to the TSO panel, who can enumerate CICS, and this will walk through. And as it doesn't really parallelize too well, just because probably sloppy coding. But as you go through all these and you go to system enumeration, if you go up to findings over here, it will actually generate like an HTML report. Let me see. If I stop this, it's not going to work. But if I go here, maybe it will. The report, you can spit out JSON. You can spit out HTML. You can do all kinds of fun stuff. And once it's actually done and you've run through, the main thing is, and there's even methodology. So kind of, that's a big thing in the organization I work for. It's like before you actually pen test, like teach people what you're doing. I know that I've kind of sound like a broken record, but this is, ports don't define it. The VTAM, that virtual fabric crap, that's what does it. And authentication does not mean administration. They're really, really big on that. And once again, deferred execution. So while that's doing that, let me see if it actually, it's probably gonna mess up now. But if I go back here, yeah, I think it's actually still running. So I'll give that a second. What else? I could open up another window, I guess, modern technology. See, it's actually going through here and trying different users. It's not super fast. I basically ported this to, whatever this is called. I stole it from Soldier or Fortran, just like everything else. I'm not going to take credit for it, but it'll walk through and it'll create like a nice little report. What else can I show you guys? So you could actually see the console. You could see it enumerating, the users. One of the biggest hurdles I came with this, and there's a little AI, kind of tells you what's going on. Red Team Tutor. So I'm going to leave this open. Hope it works. This is what I kept on clicking on by mistake because there's. This will walk you through, and this will completely break the other thing. It will walk you through see, it's because it's logged in with, are you guys seeing that? Why are you not seeing that? Did I highlight? Yeah, okay. So it's actually going to say like, you're seeing the output from the VTAM enumeration. So if I disconnected and reconnected, or most likely I just have to like kind of blow up the server. So I'll stop it, start it. I'm not messing around when I'm on stage. The disconnect connect thing can kind of be a little bit shysty just because it's a freaking 80s mainframe. So it's finicky, and you try to cram AI and do any kind of logic. It gets kind of interesting, but it comes up relatively quickly. It was one of the main reasons why I bought this fancy notebook. But in all honesty, my previous notebook was basically just as fast. I got it for the you need more advanced models to do some of the RAG stuff. The RAG stuff is kind of cool, like you saw. But this will actually walk you through once it comes back up, and it has all these cool sessions, and these actually work. So this will teach you how to kind of actually hack a mainframe. These are all Philip Young's. I call them out like down here. These are the labs that he gave in DC30. There's a really cool buffer overflow. And you can walk through this. You can use the analyze screen to kind of tell you what's going on. And this way, if you ever get access to a mainframe, this tool is pretty benign. I mean, it's not going to start dropping, crazy JCL, or it's not going to try to upload to your FTP server. In the essence of time, I know that I'm running out. I'm fine. All right, cool. This is the RAG database, which honestly gives me a little bit of, let's see if is it loading or is it, yeah. So You feed it a bunch of PDFs, and then you use obviously the correct LLM parser, and it's pretty badass. Like this thing, without this and without a decent model, this information is just not in. It's not in Claude. It's not in OpenAI. It's very esoteric knowledge. So you have to kind of, without training in an actual LLM, I found that using a decently powered LLM and kind of basically just feeding it, go out, get every single IBM Red Book you can have. And it worked. I was kind of like, awesome, Architecture, really quickly, kind of a little AI generated here. I'm not that smart to create such a cool looking thing. But it runs you through the whole system. This is MVS 3.8. It's a turnkey solution. You can download it. It's literally from the 80s, and everyone's kind of pitched in. This is what Solitaire Fortran uses, just because he doesn't want to get arrested by various, authorities. The last thing I can kind of run through really quickly is, where am I? Assess, and yeah, there's kind of a cool graph, like a graph theory, that's broken. And the models, the abstract models, which walk you through the boring text stuff, which I didn't want to bore you with. It's kind of more fun. And then you can actually just have like a full-blown, where is it? I can't see, AI chat. So it will show you the screen. You can then do whatever you want. You can highlight the screen. You can play around with it. I didn't even know you could do that. And this is where you can have a couple questions that'll be answered by the RAG. So this is kind of the same question I asked before. It's just a little bit more slimmed down. And if you ask these questions just to a normal, your whatever Dan called those, like I'm not the best AI guy. API docs, so you can talk to it via more modern systems. And I think that's about it. Like I think I've gone full circle here. And FTP client, that's it. Just because that's the main way you compromise these guys. So all the stuff I showed you from Soldier or Fortran are all where he uploads basically a JCL file, and that's executed by Jez. And I know that I was kind of tangential. That's the way my brain works. ADHD for the win. You got to weaponize it. So yeah, that's my mainframe demonstration. I hope you guys are not afraid to touch a mainframe. And you can always kind of lean back on some of the information here. I work on it all the time. I'm constantly committing. And like I said, it's completely open source. If any of you guys feel free to commit, feel free to fork it, do whatever you want. I know that there's a lot of people who know more than me. I'm a little bit rusty, so I was learning along the way. And that's about it. That's all I have to say.
Thank you.
Thank you.
All right. Thanks so much.